Here we have question 8 in 2022. Gina researching fuel consumption in cars. She finds the following data for the number of miles per gallon for 8 different cars, and they're labelled A to H when driving in the city and on the motorway. So the scatter plot below shows the data for cars A to F, and you're asked with G and H on 30, 40, 30, 40. And 1730 and label them. So G and H 1730. 15 is here, 17 and 30, so just before halfway, about here. G and H. Labeling points in the leaving cert. On the scatter plot, draw the line of best fit, the line of best fit, the line of best fit even, by eye. You know, they don't mean draw it with your eye, they do mean use a ruler in some sort, try and get half the data on each side and get a line through the middle of it. Two other cars, K and L, have miles per gallon, values given in the following table. Use your line of best fit on the scatter plot to fill an estimate for each of the two missing values. So 20 for K, what would 20 approximate to our line of best fit here? Would approximate to just, I'd say, under 30. So 20, 29, let's say. And then 60, high value is 60, so we're looking up the Y value. We didn't continue all the way, but so we're looking for somewhere over here. 45 maybe, bang on the line, 45 we'll say. There will be a margin of error here. I'm probably outside it, having not used the ruler. Based on the data, would you be more confident with the value you estimated for K or L? Give a reason. Well, definitely K is within the data set, isn't it? K is kind of down here. K. L is up here, which is outside. So I would definitely say that we'd be more confident with K as it's more inside the data set. You can write that reason yourself. And then the correlation coefficient, type in all those data points into your calculator. Do it a couple of times, you should get 0.966. So it's a slope that's pretty close to 1 if we look at it. A slope that's pretty close to 1. We take here, out 3, up 3, it's a slope pretty close to 1, just off 1, 0.966, so we can see that we're pretty close there with the calculator, or maybe exact. The scatter plot on the right shows some values of fuel consumption for the given values of engine speed. For the point of this scatter plot, f can be closely approximated to a quadratic function, we can see that. And then they've given us this RF of S, the correlation coefficient between F and S based on the points. Give a reason why this is very close to 0. Well, we just mentioned slope. That's kind of say a positive correlation coefficient, a negative correlation coefficient. But if we don't have a slope, which we don't within this quadratic in a curve situation, I would say quadratic function. So I'd say quadratic, no slope, well, no identifiable slope. There is between maybe two of the points, but not creating some sort of line of best fit. Part C, we have 13 customers rating their experience in a garage out of 100. Mean was 52. Well, what's 13 by 52? We'll get the total. 13 by 52. $650 and 26 is 676 will be the total. Let's work out what these add up to. All of these guys into a calculator. It's giving me 534. So 534 plus S plus M must be equal to 676. So here's our starting point. S plus M have to be equal to 1 143, where's that? 142. So what are we told here? The median as well is 54. So we need to rank all these numbers now, highest to lowest. So let's see, can we do that? 24. Put a line here, 24. 28 is next. Just double check. 30. Definitely those two, 28, 30. Then we're going to have the 40s. What have we got? We have a 42 and a 46. Then we have a 50 and a 54. Take your time always. And it looks like then we've 3 left, 61, 68, 74. 61, 68, 74. And I'm pretty sure I left out the 57 at the end there. It didn't go in. 60, 50, 54, 57. I didn't write down 57. Counting them, 61, 68, and 74. And just count them, 2, 4, 6, and then we have another 5 is 11. So we have another 2 to put in. And we're told that the median, the one in the middle, is 54. So the middle of 13 was 6.5. So we'd have to have 6 above, 6 below, and the one in the middle will give the 13th. So count down 6. And you see that 54 is here. There's 6 above it already. So we need 6. We need 6 below. So the two numbers need to be below, and they need to add up to 142. We were also told no two numbers were the same, so the lowest number can be in here at 55, meaning that the highest number, if we take 55 away from 142, we're going to get 87, and that would actually be down here, look, 87. So 87 is the largest, 55 is the smallest. Values that these could be, either of them. Part D, we're told John bought a car a number of years ago. The table below gives the estimate of probability of the following 3 events happening. The head gasket blows, the timing belt goes, or the air filters break. If the head gasket blows, John will have to replace his car at an estimated cost of 20 grand. And the probability of that happening is 0.095. That's going to give 950 by 2, 1900 is the expected value of that happening. If it blows, it will cost 1450 to replace now. 1450 now. Or take a chance and it costs you 20 grand. If it blows, the expected value is 19. You're asked to figure out which one is the best thing to do. Well, I think you should get it replaced now. What do you think? It's only costing 1450. Get it replaced now. Don't take any chances. Don't think they're looking for much else here. I suppose we do have to bring in the cost of it blowing next year if it does get replaced, which is the 20,000 by 0.005. That will give 100. So it's actually 1550 versus 1900. The risk of having to replace your whole car. I would get it done now. The last part, work out the probability at least 1. So minus the probability of none happening here. You see at least 1 and it's given in bold. So the probability at least one of the events in the table above happens to John's car this year, taking the events to be independent. So what's the probability of them not happening? 0.905 multiplied by 1 minus this guy. If it not happening, it will be 959. 0.959 by the probability of 1 minus this, 927, 0.927. On a calculator, this is going to give 0.8045. So that's the probability of it not happening. 1 minus 0.8045 is equal to 45. 0.1955 for the last part of question 8.